cloud. I'll record to this computer. Okie day. Just before I get started, I'll mark the roll. Shit. Force is here. Yusuf, you're here. Look, yeah, it's Friday, guys. I'm not gonna pick you out if you if you're here. Just put a thumbs up. You don't even have to unmute yourself. But if I see your name in the chat, I'm gonna mark you present because we're chill. Grace, Haley, Maddie, Adele. Yes, you are here. Zach, Michelle, Daniel's gonna be marked present. Matt, Uma, Buddha.
I'm here.
Thanks, Matt. Thanks, Uma. Who's Buddha? Buddha's not here. Arafat, you're here. Good stuff, man. Teresa, Gordon, and Coda. All right, everyone's here except for 2 people. Who are they? Arati and Huda. Yeah, all good. I just realized our class size has gone to like a total of 17 people. That's cozy. I like smaller class sizes. And look, that's a... Sorry?
What was the start?
At the start of the year, or like towards the end of semester 1, there was like 25 people in our class. A bit much.
I don't remember the other 8. Only 1.
Yes, I can't recall any of that.
Ramina, we had Myrna, we had
Serena,
Iram, yeah, Serena, Malik, yeah.
Oh, Chile.
Yeah, so a fair few other people, Muhammad Admedan, you know, and like, this is interesting because semester 2, this is like, everyone's refining, it's refinement. So it condenses, but the people that are left back, you'll see that, you know, you still have people who don't do as much work, but I think generally speaking, the whole class gets tighter and you realize like, oh shit, it's like, we're the 100. And for the people who stay back or the people who continue, you see like their character develops a lot more. Okay. Yes, I binged the 100 and I actually pulled an all-nighter on Wednesday night. Yeah, so yesterday night.
Ask you.
Yep, and I finished season 7.
They leave you on a cliffhanger. There's no season 8.
Yeah, well, I guess there was closure. There was closure in the fact that, you know, they chose their friends. Yeah, it is. Honestly, the show just goes off the rails after season 4. Yeah, that's true. It's like, but the interesting thing is that the last episode was the 100th episode and they ended it on the dot. Yeah, so I found that one interesting. Anywho, let me share the 100.
Oh, okay.
Yeah. So look, guys, today we're going to continue with the exercises. We'll see. Yesterday, off record, like it was a bit slower than usual because we were being observed and we wanted to, you know, spend more time focusing on these kind of skills rather than getting through the content. I'll rush through the content. And the good thing about this is that it's being recorded. So if you've forgotten what I've said, then you can definitely go back and watch the video again on YouTube. And you can, instead of watching it at like ×1 speed, watch it at ×2 speed or ×1.5. That's how I did my lecture notes back in high school. I would just watch at 1.5 speed, at least. And if I didn't get it, I'd rewind. That's the great thing about, you know, online learning and having videos. You can actually rewind and watch it again. So then you can process it again and see what kind of things you missed. Because right now when I'm speaking, you'll probably only capture like 50, maybe 60%. Sometimes if you're not fully awake yet at 10 a.m., you're only capturing about 40 or even 30% of the information that I say. So it's important to go over this. Maybe at the end of today, watch it or skim through it again. Go through the parts that you weren't sure and just revise. That's my kind of revision, you know? And then if you're feeling good, then maybe try a question or two just to see if you actually understand it, because watching and just listening is different from, you know, sitting down and actually doing it. So picking up from where we are on yesterday, we were doing, yes, 8F, or well, we're still on 8E technically. We're supposed to be doing 8G today. So let's see how fast we can go through this. If there is a particular point where you don't understand, just type in the chat to me, please. Like type in the chat to me so I know that you don't understand. I can go back and try to explain it again or slow down the explanation. Okay, so it's up to you guys to, because look, you guys are old enough now, yeah? Sorry to put that on you, but you guys are old enough now to speak up and ask when you need help, okay? And I'm more than happy to. What do you mean by lecture notes? Did you do university? Yeah, in uni, I did uni maths. Yeah, and it was pretty cool. Yeah. People who, the lecturers in university, they do research, so they have PhDs and stuff. But the issue with university lecturers is that they are so smart. But the issue is, again, and we're bringing up like this idea from our the conversation that I had before with my friend. They don't have the people skills, so they don't know how to communicate and they don't know how to teach. They just literally blurt everything out and they're like, okay, go. And sometimes they don't even teach properly, 9 times out of 10. So you have to end up figuring it out yourself. So there can be some challenging times when you're in university, but you can't completely blame it on the university lecturer. It's your responsibility to go out, look for the resources and research and discover it yourself, okay? So let's have a look at this one here. Modeling geometric growth and decay. It says, Brian borrows $5,000 from a bank and he will pay interest at a rate of 4.5% per annum. So I'm just going to go through and I'm going to pull out this here. I'm going to pull out this here and we're going to actually label it. So this $5,000 is your starting point. That's V0. Your 4.55 is your R value. So that's little r, yeah? It's not capital R, as we mentioned yesterday. Let Vn be the value of the loan after n compounding periods. Okay, so just remember, when it says compounding periods, what kind of growth is this? Is this linear or is it geometric? Is it?
Geometric.
Geometric, okay, so make sure you kind of remember that, because when we look at geometric equations, the template for the actual equation itself is different. And I'm actually going to write that down now. Now, we actually have to figure out if we want to use the rule or if we want to use the recurrence relation. So again, it's asking us for the recurrence relation here. Okay, write down a recurrence relation to model the value of Brian's loan if the interest is compounded yearly, quarterly, or monthly. Now, this one's important here because we need to consider how often the compounding periods are. So how often is this interest being calculated? That's what compounding periods means. So let me write a note on that. I'll write out the template first, and I'll write a note on what the idea of compounding periods means, okay? So we've got, and I want you to actually flick this up in your notes You've got V0, right? No, sorry, not V0, it was Vn. It was your current term, but you're multiplying it by the common ratio. That's what that capital R stands for. And I'll label all this again. And that gives us our next term. But we need to figure out what that capital R is. That capital R is 1. Now, since we're paying a loan, but it's accumulating interest, the value of the loan will increase over time. Okay? So that's why we're doing a plus symbol here. A plus because the loan the interest on the loan increases. It accumulates. All right. Now, this idea of compounding periods is how often the interest is calculated. Because what you've noticed with simple interest before in our previous lessons is that simple interest is only calculated annually. It's only calculated every year. So we don't have to worry about, breaking it down to how like every month or every 3 months, which is every quarter. Okay. We just plug in the number of years. But with compounding interest, it can be calculated every year. So that's yearly, every quarter, which is every 3 months, or every month. Okay. So we need to understand and know when these time periods are. So, so that's step number 1 there. Write the formula. And that's obviously after you annotate the question, okay? You write a little summary about it. Step number 2, we're going to figure out what this idea of yearly is. So in this step here, we need to interpret what this idea of yearly is. So I'm going to write here, convert units if necessary. And what I mean here is this idea of yearly, okay? What is our rate at the moment?
Sorry.
What is our rate at the moment?
4.5%.
Yep. How often?
Since we're working on A, it's every year.
Yep, it's every year, but this number 4.5, that's 4.5% per annum at the moment, okay? So in this particular case here for compounding interest, per annum or per year, that's important because right now it's per year, so that's fine, right? Do we need to convert this? Do we need to fix it up or anything, or do the units match?
They match.
If they match, yep, if they match, that's fine. We leave it as it is. So the rate here stays as 4.5% per annum. Okay, I'm going to write per annum. Write it out in the full word because when it comes to these ones here, it's going to change a little. Okay. Make sure you guys look carefully at these notes and read all the fine prints. I don't write these out for nothing. I write them there so that it could be read. It can be read. Okay. So let's have a look here. We've got R equals to 4.5% per annum, which means that no conversions needed. We we don't need to convert it because we just want it to see when the interest is compounded every year, okay? Yeah, I'm going to do this for part A. So the next thing is, well, we've got all our values. All we need to do now is substitute, okay? I think step number 3 here would be, we need to find the capital R, okay? So what that means is we're going to find 1 plus 4.5 over 100. If you put that into your calculator, it should equal to 1.045. Okay. Double check that on your CAS if you have it. 1 plus 4.5 over 100. Yeah, that's 1.045. Next step, step number 4. Now you can find the recurrence relation. So here's a quick example. You're definitely going to need to go over this again when you watch the video. So we've got our recurrence relation at the top. And I'm going to put in the bracket here, use the template. So the template is here. So we've got Vn plus 1 equals to our capital R, which is 1.045 times our Vn. You can write a times there if you don't want to write a dot. Okay, that's it. That's done. Let's have a look at it without the steps, okay? Without having to write out all the steps. So here we're looking at compounding quarterly. Now remember that n is the number of compounding periods. So the number, the n there is fine. We leave it as it is. Now, with this idea of quarterly, again, we're going to start off with our template. I know we've already written it at the top. It doesn't hurt to write it again, because when you write it again, it's practice. And every time when you write out the equation or the formula, it sinks in a little more, okay? Now we want the idea of quarterly. So convert the units if necessary. We want quarterly. So what this means is that our R, it can't be 4.5% per annum, because that's calculating interest just every year. What we actually want though, is we only want to calculate it every quarter. So what do you think we should divide it by if we're calculating it quarterly?
4.
Yeah. So divide that by 4. And that's happening per quarter now. All right. Once you've got that down, we can find our capital R. Because it's 1 plus, yeah, you can write it like this on your calculator. 4.5 divided by 4 over 100. So /. Sorry, what was that, Matt?
1.025.
0.025. Okay, so that's our capital R. And then once we have our capital R,
Wrong.
yeah, I feel like it's a bit different. 4.5 divided by 4 over 100. Yeah, it's this one, bro.
Was completely thinking my bad.
All good, all good. 1.01125. So we can write our recurrence relation now. We've got step number 4 here, which means that we have we have our R, our capital R. Remember, we use our template, yeah? We're looking at this blue line here. in order to figure out what we need to put in. So we've got our capital R. Here's our capital R. So it's 1.01125 times, in blue, we've got our Vn. And that's it. You don't need to tell us what your capital R is because we've already found it. So I have 3 lines of working out, guys. That's all we need. We've just got one more. Oh, sorry. There's one thing that I've forgotten here from the recurrence relation. Can you figure out what it is that I'm missing? I've got the rule here. And in the template as well, I've actually forgotten it. I left it out. Can you figure out what I left out?
Is it the
Go back.
starting term?
Yes, that's correct. The starting term or the starting point. Perfect. Perfect. Sorry, so I forgot to write in V0 equals, yeah, I like that. Instead of saying starting point, let's say starting term. What's another word for starting term? You could also say initial. Back up there, we started with $5,000. I'm just looking at the top here. And if you actually look, you've actually labeled it as V0. Okay. I'll grab this here as well. Lock it right now. I am really hoping that lockdown lifts enough by the time we, by week 4. Hopefully it lifts by next week because I really want to go camping. Okay. I know the screen looks a bit small right now, but we'll do the question once more, okay, with this idea of monthly. So we've got to write out our template. We write out our starting term. Even though if we know what the number is, we want to write out the formula anyway. And yes, you can be copying it from the top line, but every time when you write it out, you remember it a little more. And you become less dependent on looking, constantly checking it up. So this idea of monthly here, we currently have 4.5% per annum, yeah? What would our R be if we wanted to be per month?
4.5 divided by 12.
Yeah, 4.5 divided by 12% per month. Now notice here, I'm not actually calculating what that 4.5 divided by 12 is. You can if you want to, but it's gonna be a bit of a pain when you type it in. And plus you're doing another calculation anyway. Next step, we find our capital R. That's 1 plus R over 100. Our R now is 4.5 divided by 12 all over 100. When I watch my playback on the videos, I realize that I talk really slowly. I don't know if I talk slowly for you guys to process or not, but yeah. Please let me know if I'm going too fast though. Can you just type in the chat and let me know if I'm going too fast, or is this an okay pace? I want to see responses from the majority of the people. Okay, sweet, sweet. Thanks, Arafat. Thanks, Uma. Thanks, Zach. It's okay. Yep, thank you. Cool. Haley, Grace, the people who never respond. Yusuf, Gordon, Adele, how's the pace? Yeah. Didn't get the question. How's the pace? Am I going too fast or am I going too slow?
No,
Alright.
so you're going at a good pace.
All right, sounds good. Thanks, Gordon. Okay. So just have a look here. You can see what I'm writing on the screen. I'm just topping it off with a recurrence relation now, okay? So we've got Bn plus 1, we've got our capital R, so I'm just looking here, yeah? Which is 1.00375 times our Vn, which is our current term. All right, that's it. Happy days. So I'll clean up those notes there and then I'll send it through to you once we're done. We'll continue moving on because we still got 3F to go through today and our class ends at 11:15. So I'm so sorry, guys, if I make you, like, I know your other teachers, they might hop into class and then give you like a 15-minute lesson and then tell you to like go away and do the work yourself. So I do apologize with online learning that I'm keeping you guys for the whole lesson. Unless if you don't mind that, then all good. My tutoring lessons, usually when I tutor students from other schools, I teach them for an hour and a half at a time. So 1.5 hour sessions. The reason why I want you to do this as well is because when you go into, when you've already realized now that when you sit down and do exams for an hour and a half or 2 hours, you realize that you need to develop that resilience to sit down and focus for that extended period of time. So I guess you can call this a bit of training as well. I believe this is still exercise 8E, okay? So we've got a recurrence relation already. You can see all this stuff up here. This is just preamble. It's just telling you about the scenario. Is the preamble important? I'd say so, yes, it is, because it tells us what's it actually talking about. It's talking about office furniture. Okay. And is it growing or is it reducing? Is it growth or is it decay? Is it dying off? And what tells me that? What tells us? Yeah, what's that, Matt?
It says at the top.
Yeah, what does it say? Oh, well.
Reducing balance, depreciation.
Yeah, it's depreciate. Yeah, well, in the actual question itself, it's here. Depreciating at a reducing balance. So from that there, we know it's geometric, okay? You can also look at the recurrence relation that they've given you and it's multiplied. If it was linear, if it was just simple interest or, you know, flat rate depreciation or unit cost depreciation, it would have been a plus or a minus. Whereas this one here is a multiply. Now you're wondering, well, where does this depreciating actually show up? I don't see any negatives in here. It should be decreasing, yeah? So why don't I see any negatives? Well, it's actually hidden, okay? So let me just take this recurrence relation here and I'll actually break it down for you. And I'll explain why there's no negative.
So is a 0.93 the reason?
That's correct. Well, it could be expressed as a fraction, 93 over 100, but essentially that decimal, if it's below 1, then you're actually, every time when you're multiplying it, the number gets smaller and smaller. So that 6,900 there should decrease by a certain amount. Okay. Now, that's what our recurrence relation is. I'll break this down so you can actually see. We've got our starting term. We've got our next term equals 2. Now remember what this was. This was V0. Where Vn, where R is equal to 1. Remember, it's plus or minus, yeah? The rates over 100. So in this particular case here, is it a plus or is it a minus, and why?
Would be minus
Yep, because it's
because it's
depreciating.
depreciating. Yeah.
That's correct. All right, so you can see here, I'm going to put it in a big fat red, yeah? A minus because it's depreciating. Or I'll just write depreciation. So you'll see here that this capital R, when you actually calculate it, what's our little r?
$1.00.
You know what do you know what our little r is? So I can substitute it in. It's not quite that value. See if you can type it in the chat. Yep. That's correct, Yusuf. Any other people who are going to type in chat?
So what was your question? Your voice was cutting
What?
off.
Oh, sorry. What's the little r? The value of the little r.
7%.
That's correct.
So is the rate always a percentage?
Sorry?
Is the rate always the percentage?
Yeah, the rate should always be expressed as a percentage. But you just got to be careful of the back part, yeah? And what you need it in, if you need it in per month or per years. Okay. I'm just skimming through this question here. Should we change the rate or should we keep it as, 7%? Do our units change from per annum? Are they asking for per month or per quarter? Yeah. If you scan through, just quickly scan through, you'll notice that it's talking about years, per annum. Yeah. This idea of when. So when is flexible in the sense that you can express it in whatever time period you want. So I'll go through here and I'll just underline it. So you can see R equals 7% PA for per annum. And we've got this here, and that's our V0. That's our starting term. Now you can see here, if you type the capital R into your calculator to calculate it, 1 minus 7 over 100 should equal to 0.93. And that explains why or how we get our depreciation. It's actually not above 1. So I'll write a little note here. If capital R is bigger, or I'll say is greater than Then we are dealing with geometric growth.
Right, when?
Oh, lol. Then when? Thank you. And if your R value is less than 1, then what's the situation? We have
It's
geometric. Yeah. So greater than and less than. You know what? I'll make it like this. So less than is decay and it's in red. So you make this color association. And if it's in green, then we know it's growth. It's good to go. It's going up. All right, there's a little note there. I know it's a bit tilted, so I'll just fix it up. There you go. All right. It says here, use the recurrence relation to find the value of the office furniture. Well, you think about it, you sit on an office chair or you buy a chair. After a while, do you think you can sell it for more? Absolutely not. It's going to have wear and tear, yeah? You know, you might chip a piece over here, you might break a leg over there. You can't sell it for its full price. And what's more is that you can't sell it for profit. Okay. Forrest, you mentioned a good idea there. You mentioned after n years. So I think that's something worthwhile taking into consideration. So the value of Vn is the value, okay? Vn is the value for after n amount of years, okay? So if we're looking here, it wants us to find correct to the nearest cent. That's our circumstance there, because that's how they want us to write the answer or how they want us to do the question. Another circumstance here is use the recurrence relation. So you don't use the rule, you have to use the recurrence relation, okay? We've got our recurrence relation there. We want to find it after 1 year. So after 1 year, what's our n value after 1 year? What is the value
1.
of n? That's correct. So n equals 1. So we have V0 at the moment. Remember, with the recurrence relation, recurrence means that you're repeating it over and over again. So we have to take this step by step. We start off with 6,900. Then we can find it, our V1. Okay, then we can find it after 1 year. So what that means is we take 0.93 and we multiply it by 6,900. What does that give us? 0.93 times 6,900. I'll just do this on the CAS. So I constantly want to show you the CAS. Can you just type the answer into the chat if you've already got it? Thanks, Uma. I'll just share my calculator screen here. So we started off with 6,900. And then we're taking our capital R, that's 0.93, and we're timesing it, multiplying it by our first term. Don't type 6,900, type control answer. Whoops, times control answer. Yeah, control negative, which gives us the answer. And then you may as well do it for the next couple of ones. Notice how I'm pressing control enter. Okay, so just spam it a couple of times so you can see what it comes out to. And then from there, you can answer your question accordingly. All right, so if we need to do any calculations, they're mostly already there. I might actually do a few more actually. Should just fill out the whole page. There we go. Because you never know, it might be able to answer the next question as well. All right, I'll take this and I'll go back to our document here. You can see after 1 year, n equals 1. We're finding V1 now. Now just a reminder here that each of these terms here actually represents the term. V0, V1, and you can label it if you want to. Obviously, you can't label it on your CAS screen, so you would have to do this mentally. But you can see these are all the terms after however many years. This is the starting year, after 1 year, after 2 years, after 3 years. Okay. This is actually really important here because what I've noticed is that I found myself in a rabbit hole and I stayed up really late last night because I ended up digging into we got to do it for 2 years and 3 years as well. Okay, I ended up digging into doing taxes, and that's the reason why I messaged my friend, because I thought she was able to do, like, she knew how to do her taxes. And I realized that for taxes, when you want to figure out how to claim stuff so that you don't get taxed as much, you need to know how to do a bit of maths, and you have to be really organized. You have to keep track of all your expenses. So here's a little tip: keep all of your receipts that you purchase, especially for big items. Okay, you want to keep that as a habit now. Like, even though if you don't do anything with it, keep it in like a shoe box or something. Just have a shoe box where you just chuck all your receipts in for the whole year. The good habit there is that you will be able to provide evidence, you know, because say, for example, the taxman pulls you up and says, yeah, you said on your claim here, you bought like a pair of, like, you bought a laptop. Where's the receipt for it? Can I see that you've made proof of purchase for your claim? And then if you can't cough it up, if you turn around to them and you say, oh, well, I lost my receipt, do you think they're going to care? No, they're going to be like, okay, then you can't claim this. Tough luck. So you need to be prepared, okay? Luck favors the prepared. My friend told me that. Luck favors the prepared, which means that, is there really such thing as luck? Apparently not. You just need to be prepared, which means that you need to sort yourself out. Whether or not you remember this tip is up to you. But yeah, you can see the template of how I've created that. You saw how I did it step by step. If you need to see how I did that again, please just rewind back in the video and you'll be able to see it. Talking to future self here. Yes?
Let's say I would purchase a laptop here and I have the receipt for it and I want to claim it for my tax next year, next financial year,
Yep.
will I get my full money back, or
And that's where you have to start figuring out you can't claim the whole thing and then next year buy another laptop, because it wouldn't be fair,
broken?
right? Yeah, that would be broken. You would have to claim it over a number of years. So say, for example, if you buy like a $1,000 laptop, just as an example, 1,000 is easy to work with. You have two ways of claiming it. There's a thing called, oh, what was it? Let me see. Pause on this. I'll actually show you real life stuff now. So you can actually go to the Australian Taxation Office website, and what was it? It was depreciating assets.
There's a calculator there.
Yeah, there was a calculator, but we want to go to the actual ATO website. There's two ways that you can and depreciating. Yeah, prime costs or diminishing value method. So prime costs, they mention straight line, and
Linear.
in relation to, yeah, it's linear decay. Whereas diminishing value method, that's another method that there's actually, well, you can see here. Let's have a look at this graph here and see if you can figure out which one's which. See prime cost, it's in the light blue, yeah? So you can see it's the same amount every year. You're claiming off that laptop $1,000 every year. So let's say the lifetime of your laptop is 5 years, yeah? So after 1 year, you claim $200. After the next year, you claim 200, 200, 200, 200. It ends up making up $1,000, yeah? So you claim the same amount every year. That's prime cost, which is straight line depreciation. Then you can also have diminishing value. So it's up to you whether or not you want to do prime cost or diminishing value. You can actually pick it. What do you notice about this one though? So say, for example, this is your first year of claim. You only claim $200 here. Whereas up to here, if you decided to do diminishing value on your laptop, which is the $1,000, you could claim up to $400 in the first year, as opposed to $200. So it just depends if you want to claim most of your money back on the first year, or if you want to claim back, consistently every year. So this is a perfect example of financial mathematics in action here in real life. And I was looking at this last night. I was like, oh, damn. And they actually give you like equations. They give you what to use. So everyone here, like, whether you think you're good or bad at maths, you're going to have to use it. Now, you can actually, a lot of the people that I know, they actually do their own taxes. You can actually sit down and do your own taxes. Or you can spend money and waste money and pay someone else to do it for you. Yeah? Would you rather pay someone else to do something that you can do yourself? Just think about it. Yeah. So if you actually know what you're doing, or if you learn, I'm currently learning how to do this myself. Okay. So if you put out the time and effort to learn this and how to do it yourself, you'll save yourself so much money in the future. That's all I'm saying. Yeah. And again, there's nothing wrong with if you want to, with the fact that if you want to pay someone else to do it, but if you have this skill up your sleeve, it's not a bad skill. And then what's more is that you can help your friends. You can help your family. You can help your kids in the future if you decide to have kids. Yeah. So at this point in my life now, I'm doing everything that I can to learn and build up on myself, because one day I might want to have a family and I want to have children. I want my children to know how to do this stuff. I want them to be able to do these things. So just food for thought, guys. Now, question B, we've got the question, determine when the value of the investment will be less than $5,000. Let's think about that. So we want it to be, the value to be less than $5,000. How many years is that? And can we actually look at our CAS display here and figure out after how many years?
Or
Yeah, so here's where $5,000 is. $5,000 is tucked somewhere in between there, because it goes from $5,161.56. All of a sudden, after 1 year, after 4 years and after 5 years, it just suddenly drops down to 4,800. So it happens sometime between 4 years and 5 years after. But if it's asking when, we only need to give one time, yeah? So we would say straight up 5 years, okay? So looking at the CAS, you can write down V4 equals, also here, sorry, I should have put $sign, the dollar symbol. $5,161.56. After 5 years, it's $4,800.25. So therefore, the value of the, what are we talking about again? Office furniture, yeah? Will be less than $5,000 after 5 years. There you go. Now look, it's okay if we didn't get up to 8G today, that's fine. We'll learn 8G on Monday, and then I'll give everyone, because I won't be there for Thursday and Friday, I'll give everyone the work. And the knowledge that you have from now, you should be able to answer those questions that I give you, okay? That's one. Two, that would mean that when you're answering those questions on the worksheets, you're gonna need to figure out, you're gonna have to look at your notes or look at our notes together, okay? If you are going back to on-site learning next week as well, or if we all go back, then what's gonna happen is that I want you to work in groups, work in teams, okay? Explain it and make sure everyone understands it. So more than, working in teams is better than just working by yourself, because it gives you an opportunity to, again, practice those main life skills, communicate and share your information, okay? And to work together. In a group, there will always be like someone who knows everything that's going on, and then someone who's not too sure of what's going on. So having that good mix there, or that whole environment there, gives everyone an opportunity to learn. For the people who know what they're doing, for them to explain, and for the people who are not too sure, for them to learn, okay? All right. Now, the last question here for part C, I'll just take this because It's just asking us to create the recurrence relation, yeah? We already know how to create recurrence relations. That was the first example that we did today. Oh, we still haven't finished 8F yet. Whoops. Yeah, we'll see if we can cover that on Monday. But yeah, I just really wanted to bring this home, okay? And make sure you fully understand what's going on. Let's have a look here. It is initially valued at $7,500. If we underline this, we can go through and underline the key terms here. Okay, we've got depreciating, reducing balance as one of them. And we've also got this idea of a rate as well. I hate how I'm doing it all in red. Give me a second. I'm going to use different colors so you can see here. This idea that it's a recurrence relation, we want to use our template, yeah? Maybe I'll do it this color. So recurrence relation, bam. That's V0, we're writing out the template right now. So you got your starting point or starting term. Make sure you look up your notes to find out what your template is. For me, I'm just remembering it off the top of my head. Is there anything wrong with this line that I've written here? Or is everyone happy with that?
The right.
The rate, okay. What's wrong with it?
So it's depreciating, but you wrote plus,
Yep.
which means it will be increasing.
That's correct. So you see here, that shouldn't be a plus there. That should be a minus. And that's why I'm labeling it in purple, because it comes from that word depreciating. So this is geometric. If it's a reducing balance, that's geometric. And the fact that it's depreciating means that it's decay. Okay, it's dying off. You can see this R here. That's a rate of 8.4% PA per annum. And this is, it's telling us exactly what it is. It's initially valued at $7,500. So our V0 is 7,500. So we've got all our variables here. All we need to do is we need to plug it in. What are we going to find first though? Are we actually going to start substituting in here straight away? What was our step? Do you remember what we actually found first? Did we find this first, or did we find the rate first? The capital R.
Capital R.
Sorry. Yeah, sorry. I said rate, but it stands for the common ratio. So we're finding the common ratio here. So yes, we go and find that first. One minus, we know what our little r is, sorry, it's 8.4. So 8.4 over 100. Calculate what that is. Go to your calculator, just type it in.
91 point. It's a guess.
Yeah, close. It's 0.916. After you've got that, then you can write your recurrence relation, okay? So once again, recurrence relation. I just like to write it out like that. We start off with our starting term, so now we write this section here, okay? So your starting term is 7,500. And then you find your next term. The next term is equal to your common ratio, which is 0.916. I'm just looking here. Times, so you can write the times, Vn. And remember, Vn is your current term. That's it. All right. So that's just, we've come full circle here. We've answered the question that we had at the very beginning of this lesson. All right. So what I'm going to do is I'm going to send this off. Guys, make sure you do your homework, please. It's up to you to do the homework. And I'll upload the video and all that as well. I'll send out an email. I'll do two things, yeah? I'll send out an email, and on Compass as well, I will also put that into our class notes. So if you have a look here, I'll put it in the top section there, post-class message. I'll put a link to the Zoom recording. I'll put a link to the class notes as well. And look, if you want to go back on yesterday's lesson, just press the back arrow to go to Thursday's lesson. So you can see we've got 8E, 8F. Well, sorry. Yeah, this just covers 8E. So I'll make sure I mention what it covers, yeah? And the class notes are there again, so you can just click there. All right, guys. I'll leave you to it now, and I'll catch you on Monday after the weekend. Make sure you guys do your homework, please.
Catch you on Monday, sir.
All right, take care.